Okay, let's see how we did. Notice on number 2, our biggest side length is 10. So A plus 8 has to be greater than 10, means A has to be greater than 2. That means our side lengths are 3 and greater. So 3 inches, 4 inches, and 5 inches could be side lengths. If we look at 3, we have 6, and 6 is our two given side lengths, so A plus 6 has to be greater than 6, which means A has to be greater than 0. So maybe 1, 2, and 3, or you could even use fractions there, like 1/2 and 3/4, because those are both greater than 0. Oh, but it says missing number is a whole number, so I guess we have to use whole numbers, no fractions here. On triangle 4, our largest side length is 13, so our shortest side plus 11 has to be greater than 13. A has to be greater than 2, so we have side lengths 3, 4, 5, or greater. Wonderful. Let's take a look at our next slide. The next slide asks us to do this in our notebook, and you're going to need your protractor again. So it says to draw and label triangle ABC with side lengths 2 centimeters, 3 centimeters, and 4 centimeters. So when I'm doing this, the first thing I like to think about are the two shortest sides coming together. So the two shortest sides are AB and BC with 2 centimeters and 3 centimeters. So I'm going to use my protractor, and I'm going to draw 3 centimeters, starting at 0 to the 3, and make sure you're using the centimeters and not the inches. And I'm going to label that, the 3 centimeters was BC. And then it said AB was 2 centimeters. So I'm going to make this a right triangle here, 2 centimeters, and this is going to be AB. That was 2 centimeters, and this one was 3 centimeters. Well, if we did this correctly, if I connect them, CA should be a length of 4 centimeters. And it looks like, well, it looks like I'm going to have to probably open up AB a little bit. So, and this is why it's so nice to be able to use a computer to do this. So it looks like I need to draw from C to 4. So maybe go a little bit past it to 4 centimeters. Then let's see if we can draw this to be 2 centimeters so it matches. Well, it looks like we need to go down a little bit. So it's kind of hard to be able to create a triangle if we don't know more than just the side lengths. Let's see, 2 centimeters. Oh, this looks a little bit better. Aha, 2 centimeters, 4 centimeters, 3 centimeters. And this one is A up here. Awesome. So again, it's going to be a little tricky to make it match perfectly, but you can do it. I really wish that I knew more about maybe an angle or something, so I could have known this angle or this angle first. Well, let's see if we know about an angle, if this is a little bit easier to do. So it says draw and label triangle ABC with measure of angle CAB to be 40 degrees. So remember, if it's CAB, A is the vertex of your angle. So we would have something like CAB, and this angle here has to be 40 degrees. Well, how do we make sure some angle is 40 degrees? Oh, well, let's use our protractor. Okay, so I'm going to use my protractor, and I'm going to make my first side length, and that would be CA. Oh, it says CA is 5 units. So you can use inches or centimeters. I'm going to use centimeters just so it fits. So I'm going to go here to 5, and that's going to be CA. And then I'm going to use my protractor. I'm going to put my vertex circle on A, and then I'm going to line this up. Notice my 0 is on the inside. My 0 is on the inside, so I want to go all the way to 40, which is right here. And I'm going to make a dot on both sides of my protractor where this line is. so that then I can use my protractor to say, okay, A has to go through these two dots, all three. Try your best. Now I know this is going to be AB, and it says AB needs to be 6 units. So I can go back and measure off 6 centimeters on my line segment, and then go ahead and erase the rest of that, and then connect the side lengths, and this was 40 degrees. That was a little bit easier because they told us an angle. Well, we're going to start on activity 3. So please pass out the paper for activity 3, and we will get started on measuring and creating triangles. Thank you for passing out the activity. Okay, for the next 2 problems, we're going to carefully duplicate using a ruler and protractor, or a protractor that happens to also be a ruler. Label the side lengths in centimeters to the nearest tenth, and angle measures to the nearest degree for your new triangle. Then write an inequality that shows the triangle inequality theorem holds, and classify the triangle based on the angles and side lengths. Let's take a look. The first thing we need to do is we need to measure the side lengths and angles of triangle ABC. So let's measure angle A first. Line up your vertex on A. Notice my 0 I'm measuring from here to here is on the outside, and it looks like this is exactly 45 degrees. Please pause the video for 1 minute for the students to finish measuring the angles and side lengths. Let's see how we did. Did you get the longest side to be 7 centimeters and the other sides to be 5 centimeters? Angle BCA is 90 degrees. Angle ABC is 45 degrees also. Okay, let's copy and label the triangle. So the first thing I'm going to do is I'm going to label and draw BC by drawing a 5 centimeter line. So from 0 to 5, my protractor's has a little dent in it, so I'm going to use the down here part. And that's going to be BC. And I chose to do that because 90 degrees has nice horizontal and vertical lines. So now what I'm going to do is I'm going to line up my vertex on C. Notice I'm using an outside number. That's what lines up with 0 to go up to 90. I'm going to put a dot on both sides of the corresponding measurement, and then use my protractor to go through all of those dots, and then go back to measure where I think A should be. And that's going to be 5 centimeters up from C. Oh, it's almost just right where my protractor line was. That's funny. Erase this part. Label this A. And then double check from A to B should be exactly 7. Oh, looks good. Oops, I forgot that I had that wiggle in my protractor on that side, so I'm going to redraw that just so it's nice and clean. And again, we want to double check and measure our angles. Make sure that this is, 45 degrees. Make sure our other angle is exactly 45 degrees. We measured this one to be 90 degrees. And label your side lengths. The next part asked me to use the triangle inequality theorem. Well, I'm going to label the triangle inequality theorem down here. Remember that says A plus B has to be greater than C. Well, our longest side length is 7, our shortest is 5, and our medianest is 5. Is 10 greater than 7? True. This is a true statement, so yes, I was able to create a triangle with those lengths. Part C asks me to classify the triangle based on its sides and angles. Well, 2 sides are the same and 1 is isolated, so I know it's an isosceles, and the angle, there's one right angle, so this is a right isosceles triangle. Perfect. Let's move on to the next problem. I'd like you to pause the video for 5 minutes for the students to copy and label the triangle, show their triangle inequality theorem statement, and classify the triangle based on the sides and angles. Thank you for pausing the video for 5 minutes. Let's take a look at how you did. So when I measured the angles, I got 120 degrees, 30 degrees, and 30 degrees. And my side lengths were 4 centimeters, 4 centimeters, and 7 centimeters. I copied my triangle. When I first copied this, I first did side BC, and then I measured this to be 120 degrees and made my line. And notice I have these little dots up here for where I measured. Then I went back and remeasured angle CAB to get 30 degrees, and again measured the angle CBA to also get 30 degrees. Perfect. Did this triangle follow the triangle inequality theorem? Well, it did. Notice that the triangle inequality theorem for this problem, A plus B is greater than C, 4 plus 4 is greater than 7 because 8 is greater than 7. It's true. Because this is a triangle that has two sides the same and one isolated, I knew it was an isosceles, and because one of the angles was greater than 90 degrees, I knew that this triangle was obtuse. So this is an isosceles obtuse triangle. Excellent. Great job, mini mathematicians. Your reflection for this lesson is a summary. Great work today, and I will see you when I return. Do your very best. Be nice to everyone.